Look at this photograph. A flat, rust-colored plain. Pale, rounded stones resting in the dirt like pebbles in a dried-up river. It looks like a desert at dusk. It isn't. Those stones are ice, frozen hard as rock. That riverbed was never touched by water. And this ground sits at nearly 200 degrees below zero, more than 1 billion kilometers from Earth. This is the surface of Titan, Saturn's largest moon. And these are the first photographs ever taken from it, captured by a single probe on a single afternoon in 2005, from a world that had hidden behind orange smog for 3 centuries. Nothing has landed there since. 20 years later, they are still the only pictures we have. So the question is simple. In the first and only images ever sent from the surface of Titan, what did we actually see? The moon is called Titan. It was found in 1655 by a Dutch astronomer named Cassini-Huygens, staring through an early telescope. And for more than 300 years afterward, it stayed almost exactly that, a point of light with a name. We knew it was there. We knew it was big. We knew almost nothing else. The problem was the haze. Titan is wrapped in a dense, smog-like atmosphere, and that atmosphere is so opaque that it hides the entire surface. Before this mission, Titan's surface was a total mystery, for one very simple reason: you could not see it. Point the best telescopes we had at the moon, and you got the same thing every time: an orange ball, a closed door. So we built a probe to fall through it. Huygens was carried to Saturn by a NASA spacecraft called Cassini. The two flew as one machine, launched together from Cape Canaveral in Florida in October of 1997. Then the whole thing spent nearly 7 years crossing the solar system. Saturn is a long way off, and there is no rocket powerful enough to fly straight there. So Cassini took the long road, stealing speed from other worlds along the way. It swung past Venus, and then past Venus again, then dropped back toward home and slingshot past Earth, and finally out past Jupiter, 4 gravity assists, 4 borrowed pushes, each one bending the path a little further out toward Saturn. On the way, it drifted close to a small asteroid and photographed it. It returned one of the most complete portraits of Jupiter ever taken to that point. And in a quieter experiment, it watched its own radio signals bend as they grazed past the sun, and found them bending by exactly the amount Einstein's theory of gravity had predicted, a century-old idea, confirmed by a spacecraft on its way to a moon. Then, in the summer of 2004, after nearly 7 years, the engine fired for more than an hour and a half and slipped the whole machine into orbit around Saturn, the first object humanity had ever placed in orbit around that world. The probe rode the entire journey asleep, waking only twice a year for a quick health check before going quiet again. For most of those 7 years, Huygens was a passenger. A sealed instrument, dormant, waiting for one afternoon it might not survive. And here is the human part of the story, the part that everything else turns on. Long after the spacecraft had already left Earth, already gone, already unreachable, already coasting through deep space, a few engineers back home could not shake a feeling that something was wrong. Not with the probe, with the way the probe would talk to the orbiter. One of them was a man named Boris Smeds, working at the European Operations Center alongside a colleague named Claudio Solazzo. Smeds kept coming back to a single, uncomfortable thought. The link between Huygens and Cassini, the entire path by which every photograph, every measurement, every last bit of data would travel home, had never been tested under realistic conditions before launch. Everyone assumed it would work. Assumptions are cheap, and this one was riding on a machine already 100 million kilometers away. Smeds was not comfortable with that, so he did something that sounds small and turned out to be enormous. He pushed. It was not easy to push. The spacecraft was in flight, the plan was set, and asking to run new tests on a mission already underway is not the sort of request that makes you popular. But Smeds managed, with some difficulty, to talk his superiors into it. In early 2000s, he ran an experiment, From Earth, he sent Cassini a stream of simulated data, fake telemetry, dialed to different power levels and different frequency shifts, made to imitate what the real signal from Huygens would look like as it fell through Titan's atmosphere. Then he watched what Cassini did with it. Cassini could not read it. Now, here is what that meant, and it is worth sitting with for a moment, because it is the single most alarming fact in the entire mission. The probe was designed to send its data by radio up to the orbiter, and the orbiter would relay that data back to Earth. Huygens was too small to shout across the solar system on its own. Cassini was its only voice. And Cassini, it turned out, had a flaw buried in the software of its receiver that would have thrown away almost everything Huygens ever said. The reason was something called the Doppler effect. As Huygens descended, it would be moving relative to Cassini, and that motion would shift the frequency of its radio signal the same way a siren changes pitch as it races past you. The engineers had known about that. They had built the receiver to handle a range of shifted frequencies. What they had missed was subtler. The Doppler shift would not only change the pitch of the carrier tone, it would also change the timing of the data riding on top of it, the individual bits, streaming in at thousands per second, and the receiver's software had no idea that timing could move. It was listening for the bits to arrive on a schedule that Titan's winds would quietly break. So, the receiver would hear the tone, and lose the words, and you could not fix it. The software was locked, Cassini was in deep space, and no one was going to reach out and reprogram it. The bug was permanent, sealed inside a machine drifting past Jupiter, discovered years too late to correct the way you would normally correct it. So the engineers did something almost unreasonable. If they could not change the receiver, they would change the geometry of the entire encounter. They rerouted the spacecraft. They delayed the probe's release by a full month, sending Huygens off toward Titan on a path where it would fall almost sideways relative to Cassini, moving across the orbiter's line of sight instead of straight away from it. Do that, and the Doppler shift shrinks to almost nothing. The bits arrive on time, the words come through. They fixed a bug they could not touch by moving a spacecraft across the sky. That is the kind of thing this mission asked of people. And it worked mostly. Hold on to that word, mostly. It comes back. On Christmas Day, in 2004, Huygens finally let go of Cassini and drifted off alone. It coasted for 22 days, silent, running on nothing but a wake-up timer. And then, on the 14th of January, 2005, it hit the top of Titan's atmosphere and began to fall. The fall took about 2.5 hours. On Mars, a landing is over in 7 minutes. Titan's atmosphere is so thick and so deep that Huygens took more than 20 times as long, drifting down throughuygens layer after layer of a sky that had never been measured from the inside. There is a small piece of cosmic timing worth pausing on. Just hours before Huygens reached Titan, an observer, standing on that moon and looking back toward the inner solar system, would have seen the Earth and its own moon pass in a slow transit directly across the face of the sun. 2 tiny dark points crossing the light. One of them, the entire human world. It did not affect the landing. It is simply the kind of coincidence that reminds you how far away all of this was happening, and how faint a thread connected the falling probe to the people watching for it. The first thing to notice is how early the atmosphere announced itself. Huygens carried an accelerometer so sensitive, the most sensitive ever flown on a planetary mission, able to feel a push of just a few millionths of ordinary gravity, that it began detecting the faint drag of Titan's outermost air at an altitude of around 1,500 kilometers. The moon reached up and touched the probe long before the probe reached the moon. That same accelerometer caught something else on the way down, something so subtle it took a strange comparison to make sense of it. As Huygens hung beneath its parachute, the delicate record of its motion held a faint, restless flicker, the probe trembling as turbulent air pushed and pulled at it. When scientists cleaned up that signal, they found it resembled, of all things, A moonquake, the record of the ground shaking that an Apollo seismometer had captured on our own moon back in 1971. 2 instruments, decades, and a solar system apart, tracing the same kind of tremor. Some of Titan's flicker was the probe stirring itself. Some of it was the wind. Teasing the two apart is work that was still going on long after the fall was over. Then came the parachutes. A small chute pulled out a larger one, about 8.5 meters across, and the probe's fall slowed to a drift. The heat shield fell away. The instruments were exposed to Titan's air for the first time, and Huygens started talking, sending everything it measured up to Cassini, which caught it and turned to relay it home. And what it measured, on the way down, rewrote the map of the moon. Start with the temperature. As the probe descended, it read the air the whole way. High up, above 500 kilometers, the atmosphere hovered around 100 degrees below 0 Celsius, but it was restless, full of small ripples and layers, warmer patches and colder patches, the fingerprints of gravity waves rolling through the sky. One layer that models had confidently predicted, a warm middle shell called the mesosphere, was simply not there. The atmosphere had a chapter missing. Lower down, the cold deepened. Near 44 kilometers up, Huygens crossed the coldest point in the whole column, a boundary where the temperature bottomed out at more than 200 degrees below 0. And then, strangely, the air began to warm again as the probe fell toward the ground, until at the surface it settled at about minus 180 degrees Celsius, under a pressure roughly 1.5 times what you feel standing on Earth. Titan's air is not thin. If you could stand on its surface and ignore the cold, the pressure would feel almost ordinary, almost home. Now, the haze. Everyone wanted to know how far down the orange fog went, and the honest answer had always been, no idea. Some scientists expected it to thin out and clear at 50 or 70 kilometers up, leaving a window onto the ground. It did not. Huygens found haze at every altitude, all the way down. The probe fell through 3 distinct layers of it, and only broke into anything you could call clear air about 30 kilometers above the surface, deep in the lowest part of the atmosphere. The ground itself did not become sharply visible until the probe was down to around 25 kilometers. For most of the descent, Titan kept its face covered right up until the end. And what is that haze made of? This is where Titan starts to feel less like weather and more like chemistry set loose on a planetary scale. High above, sunlight and energetic particles break apart the moon's nitrogen and methane, and the fragments recombine into a growing zoo of carbon-based molecules. As those molecules sink and collide, they clump into ever larger particles, and by the time they reach the lower atmosphere, they have become the orange smog that hides the world. When scientists matched the properties of those particles against materials made in the laboratory, they found a close fit to something called tholin, a gunk you can create on Earth by firing electricity through a mixture of nitrogen and methane. Titan, in other words, is raining down the raw ingredients of organic chemistry continuously over the entire moon. Here is a quiet detail to hold on to, and I am not going to explain it yet. Buried in the gases Huygens sampled was a particular kind of argon, a form that can only come from radioactive rock decaying somewhere deep inside the moon. Which means that far below all this frozen chemistry, something was still warm, something was still moving. Keep that in the back of your mind. Now, the fall was not gentle, and the way it was not gentle told us something. As Huygens descended, its radio signal carried a hidden passenger. The very Doppler shift that had nearly doomed the mission could also, read carefully, reveal the wind. By tracking how the probe's motion nudged its frequency, scientists could reconstruct the winds of Titan at every altitude, a full vertical profile of an alien sky. What they found was a moon that spins one way while its atmosphere races another. High up, around 120 kilometers, the winds screamed along at more than 400 kilometers an hour, dragging the probe eastward far faster than the moon itself rotates. Titan turns out to be what scientists call a superrotator, its whole atmosphere sweeping around the moon faster than the ground below. The only other place we know that behaves like this is Venus. Two utterly different worlds, both wrapped in an atmosphere that outruns the planet underneath. But the ride down was rough in a way no one had predicted. Above 60 kilometers, Huygens was thrown around, buffeted by sharp, fluctuating winds, a region of violent shear where the airspeed changed abruptly with height. The engineering data showed the probe swinging hard under its parachute, tipping and lurching. It suddenly went calm only when it crossed that coldest boundary in the sky and dropped into the lower atmosphere. And near the surface, the winds died away almost entirely, until at ground level the air barely moved at all, less than a walking pace. Over the whole descent, those winds had carried Huygens sideways by roughly 160 kilometers. It landed a long way from where it entered. And then there was the spin. Huygens was built to rotate slowly and steadily as it fell, turning like the hand of a clock so its cameras could sweep out a full panorama of the ground below. It carried little vanes along its side, specifically to set that spin. Except once the probe was actually falling, the spin reversed. It turned the wrong way. This sounds like a small thing. It was not. The cameras timed their shots by tracking where the sun was, and when the probe tipped and rolled unexpectedly, the sun swung wildly through their view at one point. A camera pointing down at an angle actually caught the sun directly in frame, which should have been impossible unless the whole probe had lurched around by nearly a right angle. The largest single tilt recorded was around 16 degrees before it settled. The team building the surface images had planned for a neat, predictable turn, and instead got a machine that pirouetted the wrong direction and swung like a pendulum the whole way down. It would take them months to untangle the pictures because of it. At the time, nobody could say why the spin had reversed. It was simply an anomaly, a machine doing the opposite of what its own design demanded, with no clear cause. Only later would engineers work out that all the instruments bolted onto the probe had subtly changed how the air flowed past those little vanes, quietly turning the whole thing backwards. Titan, it seemed, did not care much what our models said. It had its own plans for the probe falling through it. So Huygens fell, and it talked, and Cassini listened. And back on Earth, the data began to arrive. And then, overnight, the engineers realized that half of it was gone. Remember that Huygens sent its data on two separate radio channels, A and B, built as backups for each other, so that if one failed, the other would carry the mission through. It was a careful, redundant design. But the two channels were not identical. A handful of things had been deliberately assigned to only one of them. All of the measurements for one of the wind experiments rode on channel A alone. And so did half the photographs. The pictures had been split, half down each channel, on the assumption that both would always be there. Cassini never listened to channel A, not because of a broken part, because of a missing instruction. Somewhere in the long list of commands loaded onto the spacecraft, a single command was left out, the one that would have told Cassini's receiver to switch on and listen for that channel. The receiver sat there, powered down, deaf, while Huygens transmitted everything it had. The command had simply never been written into the sequence, and the sequence ran exactly as delivered. When the data came home, channel A was silent. Half the pictures, 350 of them, were gone forever. An entire experiment's worth of measurements, gone. There is no recovering a signal that was never caught. The probe had done its job perfectly. The listening had failed. Now, here is where the story turns, and where those nervous engineers back on Earth become the heroes twice over. Huygens carried a transmitter of only about 10 watts, roughly the power of a dim household bulb, broadcasting from 1 billion kilometers away. Common sense says you cannot hear that from Earth. But a scientist named Michael Bird, who led the very wind experiment that had just been wiped out with Channel A, had quietly arranged for a network of the largest radio telescopes on Earth to try anyway pointed at Titan, straining to catch the probe's faint tone directly, without going through Cassini at all. He was not confident it would work, He had, in fact, placed a small bet with a colleague that it would fail. It did not fail. A great dish in West Virginia caught Huygens' carrier tone first, and then telescope after telescope across the world locked onto it, at least 17 of them, all listening to a whisper from the edge of the solar system. Bird lost his bet. And in losing it, he got back much of the data everyone had already mourned. The winds of Titan were reconstructed not from the spacecraft that was supposed to record them, but from the ground. From a signal so faint it should have been impossible. That is the whole mission in miniature. A design flaw caught years too late, a command forgotten, a channel lost. And every time, a stubborn handful of people who refused to assume it would be fine, who tested and pushed and listened when they were told the listening was pointless, pulling the science back out of the dark. The rest of the strange details are quieter, so let me move through them the way the probe moved through the haze steadily, without stopping too long on any one. There was the surface itself, and how odd its texture turned out to be. When Huygens hit the ground, it did not splash, and it did not shatter. It pressed a small dent about 12 centimeters deep, bounced onto a flat surface, slid along for 30 or 40 centimeters, then rocked back and forth 5 times, each wobble smaller than the last, until it went still about 10 seconds after touchdown. One scientist reached for the perfect comparison. The surface behaved like a crème brûlée, a thin, firm crust over something soft and sticky underneath. Another put it more plainly. It was like snow with a frozen skin on top. Step gently, and it holds you. Step too hard, and you break straight through. There was a small instrument that pushed into the ground as the probe landed, meant to read the hardness of the surface. It caught a sharp spike at the very start, most likely the moment it struck one of the icy pebbles scattered across the ground. And there is a strange, human footnote to that instrument. The one that flew was not the original. The first had been damaged during final assembly, when a ceramic part was tightened wrong and cracked, and a spare had to take its place. The spare is the reason we know how firm the ground of Titan is. There was, too, the oddly deep signal that arrived after the probe had already landed. Long after touchdown, the strength of Huygens' radio tone kept flickering in a way that free-flying antennas do not. The explanation, when it came, was elegant. The receiver aboard Cassini was effectively flying through an interference pattern, the probe's transmission and its own reflection, bouncing off the surface of Titan, adding and cancelling as the orbiter moved. The signal was even detected after the probe had dipped below the visible horizon, its radio echo skimming across the ground. Read carefully. That flickering revealed that the probe was resting on the surface, with cobbled, rough terrain stretching off to the west. You can, if you like, recreate the whole effect at home with a few dollars of electronic parts and a burst of ultrasound. It is a party trick and a message from another world at the same time. And then there was the simple, maddening problem of figuring out where Huygens had actually come down. You would think the hard part was landing on Titan. Instead, one of the hardest parts was finding the landing site afterward. Cassini could map the moon from orbit with radar, but when scientists laid the probe's own pictures beside the orbiter's radar maps, they did not match. The bright highlands and dark plains that Huygens had drifted over simply did not appear in the radar at all because those surface layers were transparent to radar, which saw straight through them to the dirty water ice beneath. The boundary that dominated the probe's view was invisible from above. The clue that finally pinned it down was a pair of dark dunes about 30 kilometers north of where the probe sat that happened to show up in both the radar and the probe's images at once. That was enough to lock the two maps together, and those dunes carry their own strangeness. Across much of Titan, dunes are giants, ridges of dark grains stretching up to 100 kilometers long, marching in parallel across the plains. The grains themselves are not sand as we know it. They are sooty hydrocarbon particles, sifted down from the sky and swept along by the moon's faint winds. Huygens, by luck, had come down in one of the rare regions free of those great dune fields, a quiet patch of ground between the sand seas. And there was one image, quiet and almost unbearably delicate, in which a drop of dew appears to fall across the camera's field of view, a bright fleck of liquid, on a world where the rain is not water. So step back now and look at what the pictures actually showed, because this is the part that stops people. When the haze finally thinned and the cameras looked down, Titan did not look like an alien wasteland. It looked like home. There were hills. There were dark plains, and running between them, cut into the bright highlands, was a branching network of channels, narrow valleys that merged into wider ones, exactly the way streams gather into rivers on Earth. They ran downhill from the rough, bright terrain into low, flat, dark regions. There were shapes that looked like shorelines. There were forms that looked like islands and shoals sitting in a dark basin. The first image released to the world, taken from about 16 kilometers up, showed drainage channels flowing toward what looked for all the world like a coast. Look closer at those highlands, and the resemblance only deepens. In the bright, rugged country north of the landing site, the channels branched again and again as they climbed into the hills 4 or 5 times over, the way a river system on Earth forks into ever smaller creeks near its source. The ridges between them rose 150 to 200 meters high, with slopes as steep as 30 degrees. This was not gentle terrain. It was carved, and carved hard, by something falling as rain and rushing downhill. And nearby stood a different kind of valley, short, stubby canyons, with only a few branches, the signature of a process where liquid seeps through the ground and emerges as a spring at the base of a hill, eating away at the slope until it collapses into a cliff. Rain-cut valleys in one place, spring-fed canyons in another, dark flood plains below. Every feature you would expect from an Earth shaped by water, laid out across a moon shaped by something else. It was the most familiar landscape ever photographed on another world, and almost nothing about it is made of what you think. The rivers did not carry water. On Titan, at nearly 200 degrees below zero, water is not a liquid at all, it is rock. The bedrock of Titan is ice, frozen so hard it behaves like stone. The liquid that carved those valleys and pooled in those basins was methane, the same stuff we burn for heat on Earth, cold enough here to fall as rain and run as rivers. The pebbles scattered across the landing site, rounded and sorted by size, the way stones are sorted in a stream bed, were most likely made of that water ice, tumbled smooth by liquid methane the way a mountain creek rounds a stone. No pebble larger than about 15 centimeters was anywhere in sight, and the small ones were rare, a landscape sifted and arranged by flowing liquid, just not the liquid we know. Even the dirt is different. What passes for soil on Titan is, in part, that orange organic haze finally settling out of the sky, the tholin gunk drifting down, generation after generation, and collecting in the low places. It is a world where the rain is fuel, the rocks are ice, the sand is soot from the sky, and the volcanoes, if they exist, would erupt not molten stone but freezing slush. Consider the light. When Huygens landed, the sun was fairly high overhead, and yet the surface was dim, about 1,000 times darker than a sunny day on Earth. That is roughly the light you get 10 minutes after sunset, in the last of the civil twilight, when the sky still glows but the day is gone. The sun itself, seen from Titan's surface through all that haze, would be a small bright smear about 1/10 the size it appears from Earth, no brighter, one scientist reckoned, than a car's headlight seen from 150 meters away. It would cast shadows, but soft ones, because most of the light comes not from the sun directly, but from the whole glowing orange sky. And the weather runs on a clock almost too slow to imagine. Titan's feeble sunlight lifts only about 1 centimeter's worth of methane into the air in a year, but its thick, cold atmosphere can hoard the equivalent of a 10-meter depth of liquid before it finally lets go. So Titan does not drizzle. It saves up for decades, for centuries, and then unleashes torrential downpours and flash floods that carve those steep ravines in violent bursts, long droughts broken by rare, ferocious storms. When Huygens landed, the rivers were dry, but the ground beneath the probe was damp enough that heat leaked out of it far faster than it should have. It had rained here, not recently perhaps, but not never. Here is one number that captures the strangeness better than any picture. On Earth, water is a mirror to radio waves. It reflects them intensely, with what physicists call a high dielectric value, up around 80. When later measurements gauged the great seas that exist elsewhere on Titan, the methane and ethane read a value of less than 2. The seas of Titan are, to a radio beam, almost transparent, nothing like the bright reflecting water of home. Familiar shape, alien substance. Everywhere you look on this moon, the same trick repeats. A landscape that mimics Earth, built entirely out of the wrong materials. Now, back to the thing I asked you to hold on to. That particular form of argon in the atmosphere, the one that only comes from radioactive rock decaying deep inside a world, was a message from the interior. It meant Titan is not a dead, frozen ball. Somewhere far below the ice, rock is still breaking down and releasing gas, and that gas has been finding its way up to the surface. There is a reason the moon needs that. Sunlight destroys Titan's methane. Left alone, the atmosphere would lose all its methane in a few tens of millions of years, which is nothing on a cosmic clock. Yet the methane is still there. Something keeps refilling it, most likely a slow, cold volcanism, welling up from inside, replacing what the sky burns away. The atmosphere held another quiet clue about where it all came from this time, in what was missing. Titan is one of only 2 worlds in the solar system, along with Earth, wrapped in a thick atmosphere made mostly of nitrogen. So scientists went looking for the heavy noble gases, xenon, krypton, the kind of primordial gases that should have been folded into the moon if its air had simply condensed straight out of the cloud that formed Saturn. They were not there. And the lightest of those gases, the ordinary form of argon, was more than 1,000,000 times rarer than it is in the Sun. That absence is itself a fingerprint. It means Titan's nitrogen did not arrive as free gas at all. It was most likely delivered locked inside another compound ammonia, carried in on icy bodies, and only later broken down to release the nitrogen we now see. The air of Titan, like the air of Earth, appears to have been built by impacts, brick by frozen brick, rather than simply inherited from the surrounding cloud. 2 nitrogen worlds in a solar system full of neither, that may both owe their skies to the same violent kind of delivery. And the probe found one more clue, the strangest of all, in a place no one thought to look for it. Huygens carried an instrument to listen for lightning for the crackle of storms. It never heard a thunderclap. What it heard instead was a faint, steady electrical hum in the atmosphere at an extremely low frequency, along with a hidden electrically charged layer sitting between roughly 40 and 140 kilometers up. That kind of resonance has a peculiar requirement. To ring like that, an atmosphere needs a reflecting floor beneath it, a conductive surface to bounce the signal off. On Titan, the frozen crust cannot do that job. Ice does not conduct, so what is the floor? The best explanation scientists could offer is quietly astonishing. Beneath the ice, somewhere around 55 to 80 kilometers down, under a crust that neither sees light nor carries current, there may be an ocean, not of methane, of water, laced with ammonia to keep it liquid in the cold, buried and hidden and vast. The faint hum in the sky is one of our best pieces of evidence that it is there. A machine falling through an orange fog, listening for lightning, may have instead caught the echo of a sea it could never see, sealed under a shell of ice on the far side of the solar system. That is the ending this mission was always falling toward. Not the pebbles, not the rivers. The possibility that Titan hides a buried ocean, and that somewhere in the chemistry raining down from its sky and the water waiting beneath its crust lies a record of the ingredients that, on one other world we know of, eventually became alive. Huygens was never built to last on the ground. Its designers hoped for maybe 30 minutes of data from the surface, if the probe survived the fall at all. It survived, and it kept talking well past that half hour, on and on from the frozen ground, sending back the same patient view of its surroundings until, at last, the batteries ran down and the cold took it, and the signal from Titan went quiet. It is still there. It has been sitting in that orange half-light for 2 decades now, a small, silent machine on a plain of ice pebbles. Its parachute collapsed somewhere nearby. Everything slowly dusted the same rust color as the ground. It remains, to this day, the only object humanity has ever landed on a world in the outer solar system, and the most distant landing we have ever made. Every photograph we possess from the surface of Titan came from those few hours in January of 2005. There are no others. There has been nothing since. The orbiter that carried it, Cassini, kept working for another 12 years, circling Saturn, confirming from above what Huygens had glimpsed from within, that Titan's poles hold true seas of liquid methane and ethane, real bodies of alien liquid with real coastlines. It found one great northern sea filled with almost pure liquid methane, its floor coated in a sludge of organic material. It found smaller lakes scattered across the moon, including one not far from where Huygens had come down. Sitting in a region so earth-strange, it had been named for a mythical paradise, a tropical pool of liquid on a world nearly 200 degrees below zero, roughly half the size of a large terrestrial lake and at least a meter deep. Then, in September of 2017, running low on fuel and unwilling to risk crashing into a moon that might harbor life, Cassini was deliberately steered into Saturn itself, transmitting to the last second before it burned away in the giant planet's atmosphere. The mission that gave us our one look at Titan's surface ended by throwing itself into a storm larger than the Earth. And now, we are getting ready to go back. A new mission called Dragonfly is being prepared, not a lander that sits in one place, but a rotorcraft, a machine that will fly. It is scheduled to launch no earlier than 2028 and to reach Titan in the mid-2030s, arriving after a journey of its own, roughly 1 full Titan year after Huygens made its fall. And here is the quiet thread that ties the two together. The winds Dragonfly will fly through, the density of the air it will push against, the temperatures it will meet on the way down, the best map we have of all of it is still the one Huygens drew, falling and tumbling and spinning the wrong way 20 years ago. Every future visitor to this moon will descend along a path first measured by a probe that is no longer listening. When Dragonfly arrives, it will hop from place to place across the dunes and the crater floors, sampling the organic chemistry that Huygens only glimpsed, asking whether the ingredients of life ever took the next step on this cold and patient world. But that is still ahead of us. It has not happened yet. For now, there is only the one machine, and the one afternoon, and the few hundred photographs that survived a lost channel and a backward spin and a bug we could not reach. We built a probe and slept it for 7 years. We caught a flaw we could not fix and flew around it. We forgot a single command and lost half our pictures, and then heard the rest of the mission in a whisper from a dim bulb 1 billion kilometers away. And at the bottom of that long orange fall, a camera opened on a shoreline, hills and rivers and rounded stones and the soft light of a late twilight, a place that looked, for one impossible moment, exactly like home and was made of nothing we have ever stood on. We have been back to look at Titan from orbit many times. We have touched its surface exactly once. And the more of that single afternoon we decode, the larger the moon becomes, and the smaller we feel standing under it, a whole hidden ocean, sealed beneath the ice, humming faintly in a sky we only ever fell through, waiting on the far edge of the solar system for us to work up the nerve to come back.